Hey everyone, in this video we're going to learn how to graph exponential functions. So jumping right in, our first example is graph y equals 2 to the x by creating a table of values. And this is always how we start when we're not sure what the graph looks like. So we're going to set up our table, x and y. For x we're going to go from -3 to +3. Normally we use -2 to +2 a lot, but in this case I want a few more points to help us plot this graph. Now I'm going to skip over the negative inputs and start with 0. So 2 to the 0, that's going to be equal to 1. 2 to the first is 2. 2 squared is 4. And 2 to the third is 8. Now what about those negative inputs? Let's actually plug those in. So y equals 2 to the negative first. If we remember our properties of exponents, negative exponents reciprocate. So that's going to become 1 over 2 to the positive first power, which is 1/2. And then we can plug -2 in, so y equals 2 to the negative second power. So that becomes 1 over 2 squared, which is 1/4. And y equals 2 to the negative third power becomes 1 over 2 cubed, which is 1/8. Okay, so we can plot these points. So 0, 1, 1, 2, 2, 4, 3, 8. And then for our negative inputs, we'll have to estimate. So -1, 1/2. -2, 1/4, -3, 1/8. So now we're going to connect our points. We're going to go along the x-axis and then up through our points. So this is our graph of y equals 2 to the x power. And this is what the graph of an exponential function looks like. Now we're going to use this graph to answer a few questions. So what is the y-intercept of the function? So remember, that's the point where x equals 0. So we have 0, 1 as the y-intercept. Will the function have an x-intercept? Well, if we look at our values, as we start to plug in smaller and smaller negative numbers, right, we went -1, -2, -3, we start to get fractions. Now the fractions become smaller and smaller and smaller, but they're never going to be equal to 0. And if they're never equal to 0, that means that we're never going to have a point whose y-coordinate is 0. So will the function have an x-intercept? The answer is no. And the reason is that 2 to the x will never be equal to 0. Right? You can try and think of an x value that would make this true, but you would never be able to come up with an answer. Okay, and that's an important fact. An exponential function in the form like 2 to the x or 3 to the x is never going to have an x-intercept. State the domain and range for the function y equals 2 to the x. Okay, so we'll start with the domain. Well, we can plug any x value we want in, right? Negative numbers, when we plug them in, just give us fractions. And then to the first, to the second, to the third, that was all fine. So our domain is all reals. So from -infinity to infinity. Now our range, as we plug in smaller negative numbers, so -5, then let's say 2 to the -10th, 2 to the -100th, we get smaller and smaller fractions. We already discussed that we won't ever get 0, but the fractions will get really, really small, really close to 0. So our range is going to be 0 to infinity. Notice I didn't use a bracket here because we can never be equal to 0. Right, so as an inequality, that's y is strictly greater than 0. Now, why is this the case? Well, the graph of y equals 2 to the x has a horizontal asymptote. And a horizontal asymptote is a horizontal line that the graph of a function approaches as x goes to infinity or -infinity. And in our case, that horizontal asymptote is the x-axis. The x-axis is a horizontal line that the graph approaches as we go to negative infinity, but it never actually touches it. So what is the equation of the horizontal asymptote of the graph of y equals 2 to the x? Well, it was the x-axis, which has an equation of y equals 0. And most of the functions that we're going to graph today, this is going to be the horizontal asymptote. In the next video, when we start to look at translating these graphs, this equation could change. Is the function y equals 2 to the x increasing or decreasing? So as we move from left to right, is the function going up or down? Let's go back and look at it. So as we go from left to right, the function starts really small, right? Small fractions, and it's growing, and then it starts to grow very quickly. But as I move from left to right, I'm constantly moving up, which means that the function is increasing. Okay, so as x goes from left to right, from negatives to positives, the function, the y values are going up. The function is increasing. Okay, so now we're going to graph a few more exponential functions and answer similar questions. So graph the following functions by creating a table of values, state the domain, range, horizontal asymptote, and if the function is increasing or decreasing. So our function is f of x equals 1/3 all raised to the x power. So we'll start with our table of values. Now for this function, we're going to go -2, -1, 0, 1, 2. So if we input 0, let's start with 0. 1/3 to the 0, that's just 1. 1/3 to the first, that's 1/3. 1/3 to the second power is 1/9. And then if we plug in a negative exponent, so I'll do that over here. So let's say f of -1 equals 1/3 to the negative first. So again, if we remember our properties of exponents, that's going to be 3/1, which is just 3, to the positive first. So f of -1 is equal to 3. Similarly, if we input -2, we'd have 1/3 to the negative second, which becomes 3 to the second power, which is 9. So we have -2, 9, -1, 3, 0, 1, 1, 1/3, 2, 1/9. So now we're going to connect our points. I'm going to go backwards here. Okay, so there we have the graph of f of x equals 1/3 to the x. Now notice this exponential function is going down, right? So in this case, it's a decreasing exponential function. And we'll answer that as part of our questions. So what's the domain? Well, the domain is all reals, -infinity to +infinity. What's the range? Well, as we plug in positive x values, we're going to get fractions that are smaller and smaller and smaller, but none of those fractions will ever be 0. They're going to get really close to it, but never actually reach it. Okay, so our range is 0 to infinity, parentheses around both, and we're not equal to either. The horizontal asymptote, as we just talked about, we're getting closer and closer to 0. So that means y equals 0 is the horizontal asymptote. And then increasing or decreasing, well, we already mentioned as we go from left to right, the values, the y values, are getting smaller. They're going down. So the function is decreasing. Same directions. Now we're going to graph f of x equals 3 to the x. So we'll set up our table of values. So we'll go -2, -1, 0, 1, 2. So 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. 3 to the negative first is 1/3 to the first, which is 1/3. And then similarly, if we plug in -2, we're going to get 1/9. Now I didn't mention it in the last example, but this one's similar. The reason I don't include -3 or 3, well, 3 to the third is 27, and that's not going to fit on our graph. And then 3 to the -3 would be 1/27, which would be really difficult for us to even try to show on our graph. So we can use these 5 points. So we'll start with 0, 1 again, then 1, 3, 2, 9, -1, 1/3, and -2, 1/9. And we connect our points. So we start along the x-axis, go through our points, and there we have our graph of f of x equals 3 to the x. So as we go left to right to determine the domain, well, that's all reals. So -infinity to +infinity. The range, well, we start with those really small fractions that never actually get to 0 and then go up from there. So we're going 0 to infinity. The horizontal asymptote, well, we get close to the x-axis, and that's y equals 0. And then increasing or decreasing. Well, as I work from left to right, the y values get larger, so our function is increasing. Now our function is fx equals 1/2 raised to the x. So we'll create our table of values. So in this case, we'll go -3 to 3 again. Okay, so 1/2 to the 0, that's 1. 1/2 to the first, that's 1/2. 1/2 squared is 1/4. 1/2 cubed, that's 1/8. If we plug in -1, well, 1/2 to the negative first is 2 to the positive first, which is just 2. 1/2 to the negative second is going to be 4. And 1/2 raised to the negative third is going to be 8. Okay, so now let's plot our points. So -3, 8. -2, 1, 2, 3, 4. -1, 2. 0, 1. 1, 1/2. 2, 1/4. 3, 1/8. Okay, so again, I'll work backwards here. So going along the x-axis, going through all of our points. So there we have our graph of f of x equals 1/2 to the x. So as we go left to right, our domain is all reals, -infinity to infinity. Again, that means we can plug any x value that we can think of. Our range, again, the fractions get smaller and smaller and smaller, closer and closer to 0, but never actually get there. So our range is 0. That's not a very good 0. 0 to infinity. The horizontal asymptote, so again, the values get closer and closer to y equals 0. So y equals 0 is the horizontal asymptote. And then as we go from left to right, the y values are getting smaller, they're going down. So our function is decreasing. Graph the following exponential function on the given restricted domain. Determine the range of the graph. Okay, so this isn't something that we've seen too often, but they're giving us a specific domain to graph on. So they're saying specifically, use only x values between -2 and 1, including -2 and 1. Nothing else. Okay, so we'll set up our table of values. But now we're just going -2, -1, 0, 1. That's it. Okay, so 4 to the 0, that's 1. 4 to the first, that's 4. 4 to the negative first, well, that's 1 over 4 to the first, which is 1/4. And then 4 to the negative second, that's 1 over 4 squared, which is 1/16. Okay, so -2, 1/16, -1, 1/4, those are estimates. 0, 1, 1, 1, 2, 3, 4. Okay, so now, here's a really important part. I'm starting at this point, ending at that point. I'm not going past that. So I start at this point, I go through to here, and I stop. No arrows. I don't want the graph to continue. I just want specifically from x equals -2 until I reach x equals 1. Now the range, tough to get off the graph. And again, this is f of x equals 4 to the x. Much easier to see the range on the table of values. So the range here, well, the lowest y value is 1/16. And the largest y value is 4. Okay, so that's our range. If we want to write it in interval notation, that would be bracket 1/16, comma 4 with a bracket. Now they could throw this restricted domain on any of the functions that we've graphed throughout the year. They just, in this case, thrown it to us with an exponential function. Determine whether the following exponential functions are increasing or decreasing on their entire domain. Okay, well, in order to do that, let's go back through our examples so far. Okay, so y equals 2 to the x. The base was 2, increasing. f of x equals 1/3 to the x. The base was 1/3, decreasing. f of x equals 3 to the x. The base was 3, increasing. f of x equals 1/2 to the x. Base was 1/2, decreasing. f of x equals 4 to the x. I didn't even ask increasing, decreasing, but we can see it's increasing here. Base was 4, increasing. So if we had to generalize in an equation, y equals a times b to the x, b is the base. If the base is between 0 and 1, we're decreasing. And if the base is greater than 1, we're increasing. Now, important that the exponent is positive x before we make our decision, but in these 4 examples, it seems that all of them have a positive x in the exponent. So f of x equals 6 to the x. So the base is 6, right? b equals 6. So that's greater than 1, so our function is increasing as we move from left to right. f of x equals 0.2 raised to the x. Okay, so our base is 0.2, so that's between 0 and 1, which means our function is decreasing. f of x equals 3/8 raised to the x. Well, our base is 3/8. That value is between 0 and 1, means our function is decreasing as we go from left to right. f of x equals 5/4 to the x. So our base is 5/4. 5/4 is greater than 1, so we're increasing as we go from left to right. Important to actually look at the value. Don't make an assumption, oh, if it's a fraction, it's doing this. Because we can see 5/4 is a fraction, but it was a fraction that's larger than 1, so this function is going to be increasing as we go from left to right. Okay, so the main focus of this video is graphing a basic exponential function. So practice with this, and then move into the next video where we're going to look at applying our transformations to exponential functions. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.